So what I wanted to do is give you a little bit of a factoring review. So what I did was I took the chapter test from the end of the chapter 7 and I pulled it out, and I want to just show you how I would look at these problems and what I would do to start them. So if I look at them in general, so all these problems in general, what I notice is that some of them you can pull a number out, you can pull a term out. Like this one you can pull a term out. This one you can pull terms out. Um, what else? This one you can use U substitution. This one you can pull a term out. So if you can ever pull a term out, okay, if you can ever factor a term out, you do that first. So the first thing you do is you factor out any common factors. Any common factors. Greatest common factor, okay? Common factors to all terms, all right? So once you do that, you might get a term, you might get a problem that is factorable in addition to that. You know, you can go further on. So if you look at number 7 here, 2d cubed, let's do number 7. So 7 says 2d cubed plus 14d squared minus 36d. All right, so if you pull out a d, if you factor out a d, you get 2d squared plus 14d minus 36. Ah, look, you can pull out a 2 as well. So if you pull out a 2d, you get d squared plus 7d minus 18. Now, at this point, the second parenthesis could be factorable into those parentheses like this, right? And it turns out it can, because 18 is 9 times 2, and 9 minus 2 is 7. So it looks like there's going to be a d here, a d here, a 9 and a 2, and the 9 would have to be positive, and the 2 would have to be negative for this to work out. So we get 2d, don't forget that, times d minus 2 times d plus 9. And that's the answer to that. Now, if you notice this, this trinomial, this polynomial of 3 terms, was factorable, but it doesn't always have to be, all right? So there's a trick to see if something's factorable, and we're going to get to it a little later on, but if you look at it, well, I'll tell you what, let's look at the numbers. So you have 1d squared plus 7d minus 18. If you call this one A, number 1 A, number 7 B, and negative 18 C, and you perform this b squared minus 4ac, b squared will be 7 squared minus 4 times a times c. You get 49 minus, actually plus, because a minus times a minus is a plus. And then 4 times 18, 18 times 4, 2, 3, 72 is 72. So we get 49 plus 72 is 121. Wait, yeah, nope. Time out. 49 and 72 is 1 carrier 1. Yeah, 121, right. And 121 is a perfect square. So if the term you get out is a perfect square, this is 11 squared. If whenever you do this, you get a perfect square, your original polynomial is factorable. Your trinomial is factorable. All right, the perfect squares are 1, 4, 9, 16, 25. It's all the numbers squared, 36, and blah, blah, blah. All right, so if you don't quite understand that, that's okay. It's not really covered in the book. It's just like a little trick. So then the second thing we can look at, so that's number 7, is if there's just trinomials that don't have anything common to them. All right, like this one. This has nothing common to it. So it's 5a squared minus 13a minus 6. So 5a squared minus 13a, is it plus 6 or minus 6? It's minus 6. Minus 6. And so if it's a trinomial, it's normally factorable like this if there's no common factor, which there isn't. No common factor at all. So there's a couple of ways you can do this. You can do this by factoring by grouping, where you'll take 5 times the 6. 5 times 6 is 30. And then you'll break 30 up into two terms that add up to the middle term, that 13. So here's 30, that's 6 times 5. 6 plus 5 is 11, and 6 minus 5 is 1. That doesn't give me 13, so I break up the 6 into 2 times 3. And so apparently 30 is, we can pair up the 5 and 3 to give me 15 times 2. That gives me 30. That adds up to 13 also. So what I can do is I can factor that into, I can rewrite the 13 into 5a squared minus 15a plus 2a minus 6. And so when you factor this by grouping, you can take out a 5a and you get a minus 3. And if you take out a 2, you get a minus 3. And so you get a minus 3 times 5a plus 2. There's a trial and error method also you can do. I'll go over that in another video if you want. So what have we done so far? So what I've done is I've said, okay, you try to factor out any common factors, all right? Once you've done that, the second step is you can say, well, if it's a trinomial, that means 3 terms, trinomial, then hopefully you'll factor by grouping, or this is also called the AC method in some books, or trial and error. It's usually going to factor into 2 parentheses like this. All right, so then I can find terms like these polynomials, 2 terms. By the way, this one is not factorable because it's the sum of 2 squares, not factorable, over the real numbers. It's a sum of 2 squares, 2 squared terms. It's not factorable. So if I see these two, there's nothing in common between b squared and 16, so I can't factor anything out. There's nothing in common between y cubed and 8z cubed, so I can't factor anything out. So either you're going to use the the difference of 2 squares, or your cube formulas. So now, number 1 said factor out any common factors. Number 2 said if it's a trinomial, you do this. Number 3 says if it's a binomial, okay, use, one of these. All right, so if you have a squared minus b squared, it's going to be a minus b times a plus b. If it's a cubed minus b cubed, this is going to be a minus b times a squared plus ab plus b squared. I want you to memorize this one, b squared. And then if it's a cubed plus b cubed, it's a plus b times a squared. Let me write the terms above, and I'll show you how you can memorize this. If you notice the terms above, this one's negative. It's a cubed minus b cubed. This one's negative, this one's positive, and this one's positive. Notice that this sign here, on this plus, is opposite of this negative. So if it's negative, you go same sign here, it's the opposite sign here, and it's always positive there. Same, opposite, always positive. So since I have a plus here, it's going to be the same, and then it's going to be the opposite, and then this one is going to be always positive. So if you can memorize the AB, it looks just like a cubed plus b cubed, AB, and then a squared, AB, and b squared. If you can memorize that, then it's same, opposite, always positive. That's how you do it. So regardless, if it's a binomial, you use one of these 3 formulas, all right? Okay, so with that said, let's do an example of one. Let's do 16 minus b squared. Now let's do number 6, y cubed minus 8z cubed. So if you have y cubed minus 8z cubed, so we're apparently going to use this formula up here. So here, the a is the y and the b is 2z, because 2z to the third power is 8z to the third power, right? You have 2z to the third power, that's 8z to the third power. So wherever you see an a, you put y, so I'm looking at this formula here, and then wherever you see a b, you put a 2z, so y minus 2z times y squared, that's the a squared, and then plus ab, so plus 2yz, and then plus b squared, plus 4z squared, that's b squared. And there you go. Now, the second one's never factorable. It's not factorable. So if you're going to use the difference or the sum of two cubes, this second term is not factorable. All right, so then if you have another one, like another binomial, say you have something like 16 x squared minus, let's say, what's a good one, 49y squared. So this is the difference of two squares, a squared minus b squared. And so that factors into a minus b times a plus b. So here the a is 4x and the b is, looks like it's 7y. So when you use this, you get 4x minus 7y times 4x plus 7y. And that's the answer. All right, so that's binomials. Now, there are some that have to be factored by grouping. So if there's 4, it's usually by grouping. So 4 terms is by grouping. So what I'm going to do is I'm going to pause the video, I'm going to grab that, I'm going to pull it over. Okay, so if there's 4 terms, so this is the fourth way, so 4 terms, okay, you really want to see, is there a common factor? First of all, you want to see if there's a common factor. If there is, you factor it out. But if there's not, then you're probably going to be factoring by grouping. Factor by grouping. So when you do that, for this problem here, it looks like out of the first two I can pull out an x and a 12. So 12x, and you're left with 2y minus 3. And on the second ones, you can pull out nothing. Nothing. So maybe this is prime. I am going to maybe switch the terms. I doubt that's going to help me at all. 24xy plus 22y minus 36x minus 33. Out of the first two, I can pull a 2y out. It gives me 12x plus 11. If I pull out a negative 3. Oh, I didn't factor this other one out right. No, wait, let's see. Negative 3. I get 12x minus 11, or plus 11, yeah. Oh, okay. I guess I could have done something like that up here. Let's see. Well, let me just finish this. So then I can pull out 12x plus 11 out, and then I'm left with 2y minus 3. All right, so let me see what happened up here. I pulled out of the first two, I pulled out a 12x. And what I'm left with is 2. Oh, I could pull out 11 of the other one. 2y minus 3. And on the other one, I could have pulled out an 11. Okay, I'm doing this late at night, so that's why. 2y minus 3. And then you 2y minus 3. And then 12x plus 11. I'm actually kind of glad that happened because it doesn't matter how you group them, you're going to get the same exact answer. So these are the same. These are the same. All right, so if there's 4 terms, you factor by grouping. All right, now, I think that pretty much does it for that. But if, here's another one. This one's kind of rough. Number 12, you probably have to, you have to notice that it's the difference of two squares, but the squares are to the fourth power. So initially you can make a4s squared, and then a squared would be 16s to the fourth, and then b would be 9t squared, and then b squared would be 81t to the fourth. Yeah. And then you work it out from there. There's more factoring after that. Now, number 15 is interesting too. With number 15, you should probably pull out an m to the 9th power, and you'd be left with m to the 3rd plus 1. And now this is the difference of two cubes, sum of two cubes. And then you use one of those formulas that we just looked at. Okay, so that's a very good problem as well. So now when it says solve each equation, what you do is you move everything to one side and you factor. Okay, so move all terms to one side, and factor, and then factor it out. All right, so this isn't always easy. One of the pitfalls that students make is here, number 18 and number 19. Let's look at 19. It's c minus 5, c plus 2 equals 18. So for 19, c minus 5 times c plus 2 equals 18. A lot of students do this. C minus 5 equals 18, and then c plus 2 equals 18. This is wrong because you can only do this if the what's on the right is 0. Okay, so for example, where all this comes from is if you have two terms, a times b equals 0, one of them has to be 0 because 0 times anything is 0. Okay, so if you have a times b, let's say, is 18, and I say a is 18 and then b is 18. It's kind of like what I have up top here, right? This one's A, and this one's B. Well, neither one have to be 18 because if you look, A could be 6 and B could be 3, and 6 times 3 is 18. So, by assuming that one of them is 18, if the product is 18, is wrong. Now, it could be that A is 18 and then B would be 1, but it doesn't have to be. So this number here has to be 0 for us to do it. So then what do you do? Well, with 19, let's get back to red. You have to multiply that mess out. So c minus 5 times c plus 2 would be c squared plus 2c minus 5c minus 10 equals 18. So this is c squared minus 3c minus 10 equals 18. And now I'll subtract 18 from both sides. Minus 18, I'm getting everything to one side. Minus 18, and I get c squared minus 3c minus 28 equals 0. And now that's a trinomial you can factor. It looks like 28 is 7 times 4, and that will get it. So c minus 7, c plus 4 equals 0. Now you set them each to 0 because you got 0 on the right. It's not a problem. So c is 7 and negative 4, so 7 and negative 4 is your answer. Now, if you want, you can always go back to the original. We got 7 and negative 4. If you plug in 7 into the first one, you get 2, and 7 into the second one, you get 9, and 2 times 9 is 18. Yeah, that works out. If you plug in negative 4 into the first one, you get negative 9, and in the second one, if you plug in negative 4 here, you get negative 2, and negative 9 times negative 2 is 18, so it checks out. All right, so then what you have are some word problems, and I think I'll do a separate video for this kind of stuff. Okay, so I hope that helps. Does this help? Send me an email and say, yes, it did, or no, it didn't, and let me know if you need anything else.